Hello everybody. Today I'm going to start off by showing you how to execute a couple of man-in-the-middle attacks, and then I'll show you how to protect against them. Now, quick breakdown of man-in-the-middle attacks for those of you who may not be aware. Basically, a man-in-the-middle attack is when somebody injects themselves between you and the router and hijacks your traffic, forcing it to go through them before reaching its next hop. How do they do that? They do that by something known as ARP poisoning. ARP poisoning is also known as a gratuitous or scandalous ARP reply. What this is basically when your computer is in the process of encapsulating a packet, it's going to look for the source and destination IP address. It finds the destination IP address, whether that be the next hop router or someone in the same broadcast domain, by sending out a broadcast known as ARP, Address Resolution Protocol. The intended purpose of this ARP is for the owner of the IP address to reply and say, hey, I got your IP address, go ahead and send me your traffic. However, the address resolution protocol is not very secure in that a nefarious attacker could reply with a scandalous ARP pretending to be the owner of the IP address where your data is intended to go, and then hijack your traffic and send it off to the intended IP address so that you won't even know that your traffic is being hijacked. I have some more in-depth information on what goes on my blog, packetninja.ca. It'll be in the video description, so you can check it out there for a more detailed explanation. But for now, let's get into the nitty-gritty of it, and I'll show you how to execute one. Alright, I'm going to be showing you a couple of different man-in-the-middle attacks, and then I'll show you how to protect against them and do some penetration testing. So first we'll have to do a little bit of information gathering. You'll want to get an IP address from the local DHCP server, make note of the subnet mask and the bit length. So we are on a -24. Make note of the gateway, which should be 1.1. And then you'll want to do a quick sweep to see which poor victim you're going to choose. Like that. I'm going to be selecting my local computer, which is a HP laptop right here. So that's 110. Before I start, I'm going to pull up a command prompt on my local computer and do a clear the ARP table. And then show you the ARP address of my local gateway before we do the ARP poisoning. So keep that in mind. We will now do the Arpspoof, which is the gratuitous ARP reply. We do that by going like this. Specify the interface, and then we have to do 2 sessions, one to capture traffic to the gateway and one to capture traffic from the gateway. So first we'll go to the gateway, and we make sure we enter victim's IP address and gateway's IP address, not your own. So we'll start this Arpspoof, vice versa one. Now, remember this ARP table from my local computer? We will see how that changes. There we go. So before it thought that it was 0980, now it believes it's 0549, and as I'm sure you can guess, 0549 right there. Now that we are capturing traffic from our poor victim, unsuspecting victim, we have to make sure we have this rule in place to allow forwarding of the packets to their intended target. Otherwise, when your victim opens up a browser, it won't go anywhere. So that command is, we'll do echo 1, then we'll go praxis. So with that in place, we can start gathering whatever information we want. Let's start with something simple like URL snarf, specify the interface. Now when the victim, aka me, brings up a web browser, we will see that information captured right here in front of us, see what they're visiting, and start gathering some more information from there. From there, another one I like to do, just for example's sake, is DriftNet. That's a neat little one that actually captures images that the victim is looking at. So we can do a DriftNet, specify the interface again, and from there, whenever the user browses to anything, for example, local sports, it's all captured right there. Pretty scary stuff. Next, we can start trying to recover some passwords. So for example, in this method, we just got to put this little NAT rule in, redirecting HTTP traffic to port 10,000, and then with that we can monitor that port using SSL strip. Then we can tail that log, and it should give us any plain text passwords that come across the wire. So let's test that out. We'll go to any website that still has plain text authentication, and we can go whatever. This is my password. And there's the email, and there is the password. A couple other methods that we can use. Well, actually one more method that we can use for capturing passwords. One that I like is Dee Sniff. So basically what we'll do is we'll do Dee Sniff. Whoops. And then from there, when we initiate something like, let's say, a FTP session, we'll do a user test password. This is my pass again. Then when we exit this session. It's right there. So the last type of man-in-the-middle attack I would like to show you is using Cane Enable. Cane Enable is by far the easiest utility to pull off one of these type of attacks. You can't get as in-depth as you can with Kali, but it has some really cool stuff. So that's why I want to show it to you. So basically, all you gotta do is click this sniffer button over here, turns it into a little wire shark, and then you want to do a click on the sniffer tab under hosts, do a scan of MAC addresses. Easy peasy. Now I can select any host that I want here and show you a lot of the same things that I did previously, but there's only one cool thing I want to show you. What I'm going to do is I'm going to go and I'm going to select my VoIP ATA, and I'm going to click on the APR tab, and I'm going to click on the plus symbol. I'm going to click my gateway on the left side and the target on the right side. OK, and press the APR button, and now we're injecting our Gratuitous ARP in the middle and pulling off the man-in-the-middle attack. Now what's cool about this, you can see here it actually will capture certs. Obviously this is an ATA, so but if this was a regular workstation, it would capture certs and actually be able to decrypt RDP, POP-S, HTTPS, SSH sessions. How does it do that? It does that by actually capturing your certificate, decrypting it, and injecting its own certificate, which is pretty scary stuff. But what I wanted to show you real quick for this example is over here under the VoIP tab. Now that's my VoIP ATA. This was a previous phone call that I had. What I'm going to do is I'm going to pick up my phone right here while we're going, and I'm going to call my cell phone, and I'm going to answer my cell phone, and as you can see, it's actually recording our conversation, if you can believe that. So that's the type of scary stuff you could pull off if you don't protect yourself from a man-in-the-middle attack. There are a couple of things we can do to protect ourselves from these types of man-in-the-middle attacks. I'm going to go over two features in specific, both of which rely on something called DHCP snooping. DHCP snooping is a feature that keeps track of dynamically assigned IP addresses and their layer 2 hosts, and it puts that information into a DHCP snooping table. On its own, it doesn't do anything to mitigate these type of attacks, but it is the key. This DHCP snooping table is the key that allows us to implement features against man-in-the-middle attacks. So in order to enable DHCP snooping, there's a couple of things we gotta keep in mind. First of all, DHCP snooping will block all DHCP offers, i.e. the replies from a DHCP server, unless we specifically state that it's a trusted source and it's allowed to provide these DHCP offers. These trusted ports also have to be applied on trunk ports. I see it very often where a segment will go down, no one has any idea why, and it's because the DHCP offers are blocked across trunk links. So to enable DHCP snooping, we go into global config mode, which we were already in, and we do IP DHCP snooping. Then we need to assign it for VLAN 1 or whatever VLAN your ports are going to be in. So we'll do IP DHCP snooping and VLAN 1. Now we need to specify the trusted source. So in this case, our uplink will be fast Ethernet 0/1. So we'll go into 0/1 and we'll do DHCP snooping trust. and that's the exact same command we have to apply on the trunk links if we have any. Okay. So the first feature we're going to use is called Dynamic ARP Inspection. Basically what that does is it protects you from gratuitous ARPs, i.e. people pretending to be an IP address that they're not. It does that by consulting the DHCP snooping binding table. So now that we have the DHCP snooping enabled and we have our DHCP server trusted, what we'll want to do is we'll want to also set any trunk links and DHCP trusted interfaces as trusted for the ARP inspection. So what we'll do is we'll do IP ARP inspection trust, so that because obviously MAC addresses coming across this uplink port will not adhere to the binding table, and then it's as easy as doing IP ARP inspection VLAN 1. After we do a release renew and request a new IP address, we will be able to see IP DHCP snooping binding. We will be able to see the binding database updated with this information here. This is Cali host, and this is the new IP address that I believe, yeah, it's a new IP address that my desktop got, or my laptop I should say, and 102 is the Cali host. So from there, if we try and commit another man-in-the-middle attack, it should be blocked at the switch from dynamic ARP inspection. And as you can see, it is, and my ARP should not be poisoned, which it is not. Alright, so the next thing we need to configure is IP source guard, which will verify that nobody is spoofing IP addresses to try and bypass any sort of layer 2 security that we might have in place. The way we configure the IP source guard is we have to go into the interface that you want it enabled on. I like to do an interface range, or it's easier to do an interface range, so we'll do range for example, and then we have to do IP verify source. So now if we exit out and we do show IP verify source, should have right there my laptop, and further to that, if I go to my laptop and set static IP address, I should be I think I gotta generate some traffic. Should be blocked. Beautiful. There we are right there. The way we get out of that is we need to go back and set us up for DHCP, and we should be back on the allowed list. Now how this works is it actually builds an on-the-fly ASIC based ACL binding layer 3 addresses to MAC addresses, so it doesn't really add any overhead. Everything's still transmitted at wire speed. It's really neat stuff. Another thing I wanted to mention is some of you might be thinking, what if you have a device on the network that that's not DHCP, a static device like a server that doesn't adhere to the binding table. Am I going to be blocked? No. What you want to do is you want to go into global config mode, and you can do IP source binding, and then from there you can do and you do VLAN 1 and interface. There we go. So now you have all the tools at your disposal to protect yourself against man in the middle, and you're also well equipped to do some penetration testing on your setup. Hope you enjoyed, and I'll see you next time.